Okay. So now we'll come to this equation, divergence of H equal to 0. Okay. So magnetic flux lines, again I can simply explain. If I take a piece of magnet, okay, having north pole and south pole, so flux lines start from north pole to south pole, again like this. Okay. I am purposely breaking this magnet into two pieces. Okay. So I am breaking this piece of magnet into two pieces. So this is a north pole, actually previously it is north pole and south pole. The moment I broken this magnet into two pieces, it becomes this particular part pole becomes south pole and this particular part becomes north. Okay, that means there is no isolated magnetic pole. There is no south pole alone. There is no north pole alone. So north pole and south pole are always attached together. Even I break this magnet into thousands of pieces, so I cannot separate the north pole alone and south pole alone. It is impossible. That means the magnetic flux lines will start north pole and should end up in the south pole. Even if we take a bigger line, it will come back. Okay, it cannot leave the source. The magnetic field cannot go away. This is not possible. This is not possible. That is what the statement given from the Maxwell's equation. So finally, this is statement we can explain. So in the previous equation, we can consider this one. So the closed surface B vector dot n cap in the n is nothing but a perpendicular vector which is moving the B vector. The dA is the area where the flux lines we are counting. So magnetic flux lines coming out of the closed surface equal to 0. This is the form we can call the integral. So again, it's a surface into volume. Again, you apply divergence theorem. I'm applying the divergence theorem. So what is the divergence theorem can do? Divergence of B vector into volume, that is equal to surface integral of B vector dot ds. Okay. So now this is the volume integral, right hand side is 0. So we can leave the volume integral. So divergence of B equal to 0. So what is the meaning? The divergence property of the B vector, that is equal to 0. That is the meaning of this statement. Right. So finally, I will come back again. Correct. So these two laws are to be discussed. So Gauss law, okay. So E dot dA equal to charge enclosed, then V dot dA equal to 0 or ES. Either you can A or S surface. Okay. So now we'll take this next law called Faraday's law. So Faraday's law actually explains the nature of time varying fields, d by dt term. Okay. So what is basic from the Faraday's law? So phi is the magnetic flux. So or simply flux. Okay. Phi b is a magnetic flux density vector. So d phi b by dt, rate of change of magnetic flux lines, and that can create the electromotive force E. That is the Faraday's law. Change of the magnetic field can induce electric field. That is the Faraday's law. It is one of the very important law. So without this law, we cannot be able to generate the electricity. Okay. So unless otherwise there is no Faraday's law, there is no electricity. So based on this particular theorem, we are now generating the electric field and we are replacing the Faraday's invention. So what it says, the rate of change of magnetic flux lines. For example, I am taking a piece of plate, metal plate. So I am allowing the magnetic flux lines through the plate. Okay. So either I am keeping the magnetic, there is a plate is a constant, the area of the plate is a constant, as well as number of flux lines crossing that particular area is a constant, then I don't find any electromotive force. Okay. If I change the area of the plate or the number of flux lines crossing, for example, the minimum number of flux lines, the flux lines are keep on increasing. That is the rate of change of flux lines. If identified, then I can find there is some electromotive force induced on the plate. So that is the Faraday's law. Okay. So this Faraday's law is a time varying nature, very important in the aspect of electromagnetic wave generation, which is very helpful to identify the existence of electromagnetic waves. Okay, so that is the Faraday's invention. We are taking the Faraday's law as it is. We are not modifying the Faraday's law. So Faraday's law is as it is in the Maxwell's equation. Then we are taking the fourth law is the Ampere's law. Very important law. Ampere says very simple. Okay, so right hand side is the current. As I said, all the electromagnetic wave equations are cause and effect equation. So right hand side is the current, left hand side is the magnetic field. So what it says, current can create magnetic field. Okay, so simply if you take a current carrying coil and supply the current I, okay, so you can find, you can observe there is a magnetic field is generated around the current carrying coil. Okay, for example, current is moving in this right hand thumb on the top side. This is the direction of the magnetic field. So this direction, the magnetic field will be generated. If you take the current flowing in the downside, this is the direction of magnetic field. So thumb rule explains about the direction of the magnetic field, and it is having curling nature. It is a rotational field. Always it is attached with the current. If you stop the current flow, then the magnetic field will be collapsed. There is no magnetic field at all. So if a stronger current flow takes place, a stronger magnetic field is generated around the coil or around the current carrying coil. So this is the Ampere's law. He to consider only the conduction current. So current can create magnetic field, and magnetic field is curling in nature. That is a state. But this is not this is actually inconsistency. It means this law is a truthful one, but we cannot use it for electromagnetic induction purpose. Okay, so this is a theorem. So current can create magnetic field. This is the recall of Ampere's law. Current can create magnetic field. When there is a current flow passing from this conductor, then there is a circular nature of magnetic field is generated. Okay, so now we will go for another look. So I am taking a capacitor. Assume this is a capacitor. In between there is a dielectric medium. This is a plate 1 and plate 2. In between there is no charges at all. There is no plates. There is no dielectric medium available between the two plates. Okay. So now this is the situation how the current flow is going to take place within the capacitor. But as per the Ampere's theorem says, Ampere says there is a current flow in the conductor, you can find the magnetic field. Okay, but in the capacitor there is a two plates which is made up of conductor, but in between there is a dielectric medium. So you know what is meant by dielectric medium, which is not allowing any electron movement, or there is no charges at all. So there is no electric field at all. This is how the dielectric medium works. There is no charges, there is no electric field. That is the nature of your dielectric medium. Okay, so allowing current flowing current through the dielectric medium is impossible. Example, plastic, wood, or the dielectric medium will call dielectric medium. Never allows the current flow or charge movement easily. Okay, so this is the nature. But how the current flow takes place? But when you take a capacitor, it will charge. It acquire all the charges. It is allowing the current flow. Okay, but how the current flow takes place? That is the question. Okay, so now charging of the capacitor or flowing the current flow in the capacitor we are assuming. So current, we are taking constant current which we are allowing to up to the capacitor plate. The green indicates about the magnetic flux which is generated or magnetic field generated up to the plate. So if you allow the charges starts accumulating on the plates. Okay, one plate it is completely charges are accumulating. So we can call it as a charging of the capacitor. So what is happening to the next plate? There is no current flow directly to the next plate. So the next plate, the charges will be induced, but it is a limited amount. Okay. So first plate acquires many charges, second plate acquires minimum charges due to induced, that we are not discussing now. So what is that? If the loop encloses the plate of the capacitor, there is no problem. I equal to 0. Okay. So this particular green indicates about the magnetic flux because more charges available on the plate 1. So magnetic flux is generated, but that is not enclosed in the plate 2. So that's clearly described in the bottom slides. Okay, right, next.